Imagine you're doing keto. Things are feeling pretty good, but you just kind of feel like you're doing the regular things now. Like you don't feel like you're shrinking fat cells as much as you were before. You don't really feel like you're getting any additional brain benefit, at least not like you did in the beginning. And then you open up YouTube to kind of like see and revamp what you're looking at in terms of research, and you find the video you've been looking at is from 2015. Maybe it's even one of my videos. So here we are in 2026 with some different rules in keto and definitely some refresher rules that need to be had. So this video is going to break down the 10 rules in 2026 that you really should be following if you're doing low carb. And we're not going to waste any time. We're just going to go ahead and just jump right into them. Rule number 1, you do not want to be relying only on MCTs. I want to clear this up right away. This is really important. MCTs absolutely have a place on keto, but they are not the foundation. Okay? They should not be the foundation of your fat intake, and fat intake in general should not be the foundation of keto anymore. Here's why. Medium chain fatty acids behave differently in the body. Okay, they are different than most fats. After digestion, they're released from a glycerol backbone, and because of their shorter chain length, medium chain triglyceride, and more hydrophilic nature, they don't travel through the lymphatic system like regular fats do. Instead, they go straight to the hepatic portal vein, directly to the liver. And then once they're there, they're really fast, like really rapidly beta oxidized, and they're converted into ketones, which we've talked about before, right? They get converted into ketone bodies, which can be used as an immediate energy source. This is great, but what that really means is this. MCTs create ketones fast. But there's a huge catch to creating ketones fast because ketones aren't just fuel. They are also signaling molecules. So beta hydroxybutyrate, or BHB, the main ketone body, binds to receptors. And this whole process is involved in regulating lipolysis, or fat utilization, right? Fat mobilization of fat cells. So when ketone levels rise, this signaling actually slows down the release of fatty acids from the fat tissue. In other words, when you get your ketones high, they help regulate their own production through a feedback loop. So the higher you get your ketones, the more you downregulate your overall fat burning. So if someone thinks more fats are good or more MCTs equal faster fat loss, they're missing the regulation piece. The body's finely tuned. So eating anything, including like regular fats to a certain degree, but especially MCTs, will temporarily halt fat loss. So you want to be specific about it. You do need dietary fat on keto, and quite a bit of it, right? You still need to eat. It's essential for fuel, it's essential for hormone signaling, but constantly eating fat is still telling the body that there's no reason to pull energy from stored fat. So fat loss can temporarily slow. It's the #1 mistake that I see people make on a ketogenic diet. Prioritize the protein, not the fats anymore. Okay, which brings me directly to the next piece. This one can really trip people up because being keto doesn't mean that your body suddenly stops needing glucose. It does need it. Your body can't ever let blood glucose drop to 0. Okay, too much glucose is harmful, but too little is obviously fatal. So the body protects itself, right? And I think people forget this. When carbs aren't coming in, we create carbs through gluconeogenesis. We make glucose from other substrates, and this process exists simply to keep you alive. It is very important. But here's the key point that we've learned from the research. Gluconeogenesis is demand-driven. It's not supply-driven. Your body does not automatically turn protein into glucose just because you ate it. Okay? It does this when glucose is required. So your body will always find a way to create glucose for the organs in your body that need it. It does this on autopilot, and you do not need to worry about it. You don't need to fear the existence of glucose on keto. You just don't chase dietary carbs as your primary fuel source. Keto isn't anti-carbohydrate, it's pro-metabolic flexibility. That's where we're at in 2026. Okay, so it'll make the next piece that I'm going to talk about make a lot more sense, because we do need to know that we can occasionally have some carbs and still get all the benefits. As a matter of fact, occasionally having some carbs, like strategically for a couple of days and then going back into keto, can actually help that signaling so we burn more fat overall. Now, this next one has to do with omega-3s, okay? Because one of the most common mistakes that people make on keto isn't eating too many carbs, it's neglecting the omega-3 fats, which become much more important on a ketogenic diet. EPA and DHA serve very specific, powerful roles. EPA is used to produce these signaling molecules that are called eicosanoids, which play a role in regulating inflammation throughout the whole body. And then you have DHA, which is critical for brain structure and brain function, brain inflammation, a number of things. So both omega-3 and omega-6 fats are stored in cell membranes. But this is where things get really interesting because long-chain omega-3s can displace the omega-6 fatty acids in those membranes of the cells, and they actually compete with arachidonic acid for the enzymes that produce what are called thromboxanes, prostaglandins, leukotrienes. Essentially, what that really means is that a relatively small amount of omega-3 massively influence how a large amount of omega-6 behaves in the body. On keto, our fat intake is higher overall, right? So fat quality really matters more. And a lot of people focus heavily on animal meats, and I often suggest leaner cuts, which can be great, but they don't provide meaningful omega-3s either way. Even if you were getting fattier cuts, I recommend leaner cuts so that you can control the quality of fats you're getting in on a ketogenic diet. But that's why it's important to deliberately include fatty fish. So you get things like salmon or sardines or mackerel, even just a couple times per week. You don't have to have it every day, right? Just a little bit goes a long way. And if you supplement it, you want to choose a really high quality fish oil in its natural triglyceride form, okay? This can matter because there's a lot of research that's been published here. For example, there's some research that was published in the Journal of the American Oil Chemist Society. This showed that triglyceride-based fish oils are much more resistant to oxidation than the ethyl ester forms, which are most of the ones that are out there. So you just want to look for the triglycerol forms. But now I want to move into something that's far less talked about, but it's hugely important, especially nowadays. Before I get into the next piece, I put a link down below for something that might help you out when you're doing a lower carb diet. We're starting to learn now that salt plays a really important role in how the brain functions. Not just from a signal transduction piece, not just from actually sending an overall nerve signal from the brain to the muscle or whatever, but also to how it impacts the hindbrain. Okay, so the hindbrain can have a major impact on the relationship with our food, our gut, and our brain. So a salt craving will oftentimes come through as a sugar craving, particularly on keto when your minerals are out of whack because you're urinating more. So your insulin levels are low, you pee more. So I put a link down below for some electrolytes that are very specific for keto, for low carb. It's called LMNT. Now they've since gotten bigger, but they were originally built for people doing lower carb, keto, or fasting. So that link down below, it gets you a free sample variety pack with any purchase. So you purchase their sparkling version, you purchase their ready to drinks, whatever, you get a free sample variety pack. They have a bunch of different flavors. They've got all kinds of cool ones coming out. They've got these ready to drink sparkling ones that are just almost like a soda, but they're electrolytes. So they have 1,000 milligrams of sodium, 200 potassium, 60 magnesium, which is perfect when you're on keto because again, insulin is making you pee more, so you're losing more of those electrolytes. So that link is down below. Probably one of the biggest hacks that you could use for a lower carb diet. So this next one, number 4, you should not ignore fiber completely because I think fiber on keto is gravely misunderstood, especially soluble fiber. Okay, because soluble fiber forms almost a gel-like substance when it mixes with water. Okay, so it's not just about how are we getting our roughage in. That gel actually slows the absorption of fats and it also slows any carbohydrates by physically enveloping them. So therefore, it has this ability to kind of bind these unesterified cholesterols. And that's cholesterol that might otherwise be absorbed. So there's an important hypothesis here. Because soluble fiber draws in water, a small amount can create a large mechanical effect in the gut. All right, so you're essentially slowing down the absorption of things. Insoluble fiber, by contrast, requires a lot higher of an intake to create the same physical structure. So what that means is you're getting a couple different things here. You don't need large quantities of soluble fiber to get the digestive benefit. Okay, instead of avoiding fiber altogether, it's better to just work your way up gradually and try to get a minimum of around 20 grams of soluble. Okay, that's all you really need. So you can use things like chicory root, acacia fiber, guar gum. These are gel-forming, inulin, glucomannan fiber. Okay, these gel-forming effects that we've talked about, you're going to get them from these kinds of sources. You can also get soluble fiber from a bunch of different low-carb veggies, right? So Brussels sprouts, broccoli, artichokes, avocado, even berries to a certain degree, right? But also focus on things like chia and flax, right? And psyllium husk is really your best friend when you're on keto. It really is a great way where you're not loading up on a bunch of fiber. You're just getting that gel-like substance formed that feeds the gut bacteria and makes a big difference there. Now, this fifth rule kind of comes back to the first thing we talked about a little bit. Ketone numbers can be useful, but they're not the full story. And I know a lot of people aren't really measuring ketones as much anymore, but this is important because here's what's happening physiologically. When carbs are scarce, fat is broken down into what's called acetyl coenzyme A. But because citric acid intermediates, especially what's called oxaloacetate, are diverted towards gluconeogenesis, making glucose, acetyl coenzyme A builds up. And what happens is that buildup activates ketogenesis, right? This is what activates ketones forming. I know it sounds complicated, but hear me out, because glucagon plays a role, and this is where things balance out. So you have this thing that's called malonyl coenzyme A, which removes the inhibition on carnitine acyltransferase, which is the rate-limiting step that allows long-chain fats into the mitochondria for oxidation. So essentially, like when you eat, this malonyl coenzyme A rises again. This makes it so that carnitine is inhibited, which means that you're not able to shuttle fat into the mitochondria, and therefore ketogenesis slows. So ketone levels naturally will fluctuate here. And over time, something else starts to happen. As your tissue becomes better at using these ketones, your blood ketones will plateau, right? Or they'll even drop because utilization catches up with production. That's kind of the takeaway of what I'm trying to get at here with all the mechanism stuff. And it doesn't mean that keto stopped working. It actually means the opposite. It means your body's become more keto adapted, which brings us to the foundation of the entire process. We just don't want to fixate on ketones being elevated. Right? We get your ketones to a certain point, then they're going to come down. So the bottom line is stop focusing on it too much. Before we get into the next rule, let's talk about what we've covered so far. We've talked about keto not being about flooding your body with a bunch of fats or chasing ketone numbers. We've talked about how your body still needs glucose, and it carefully regulates it, and that occasionally having carbs can actually benefit you. Like 1 or 2 days a week, having 30, 40, 50 grams of carbs. We've talked about how fat quality actually matters, especially omega-3s. Talked about how fiber, especially soluble fiber, still plays a role and can actually help you more with your fat burning process. And then, of course, we've talked so far about how ketone levels don't tell the full adaptation story. So now let's move into what actually determines long-term success and get into this rule number 6, which is thou shalt get adequate minerals. Super important. Okay, I talked about it a little bit briefly when I talked about LMNT, but let's go into more detail. This one is straight up non-negotiable. Okay, glycogen is stored with water. 3 to 4 grams of water for every gram of carbohydrate stored as glycogen. So as glycogen is depleted on keto, water is released. And under these lower insulin conditions, the kidneys reabsorb less sodium. So sodium, and with it potassium and magnesium, is lost, along with other trace minerals too. So sodium regulates our fluid balance outside of the cells, potassium is regulating it inside the cells, and then magnesium is playing a direct role in ion transport and muscle contraction. So if these drop, I'm telling you, your well-being will drop with them. Okay, your performance will drop. This is not about carbohydrates here. Okay, that's where people get confused. They think that they're bonking because low carbs. It's about electrolytes, and it's why you can feel sluggish and tired on keto, especially at the beginning. Okay, that's why it can make sense to deliberately supplement electrolytes like I talked about, but also just salt your food. Like all you gotta do is just add more salt and then focus on the other minerals too. Okay, now let's clear up one of the more persistent fears in sort of keto and low carb culture in general. You do not need to fear protein. One of the biggest fears around protein on keto comes from misunderstanding gluconeogenesis that we talked about before. First off, protein does not kick you out of ketosis by default. Gluconeogenesis exists to prevent glucose from falling too low, not to punish your protein intake. It's not thinking about you like that. So again, as I mentioned earlier, it is a demand-driven process. So gluconeogenesis is a slow, tightly regulated process. And importantly, its rate doesn't change very much, okay? Even across a wide range of conditions. In fact, the idea that gluconeogenesis speeds up just because more amino acids are available has not held up in a single experiment. So more amino acids, more protein does not impact your blood sugar to any notable degree on a ketogenic diet. A study that was published in the American Journal of Physiology looked at this directly. Researchers infused substrates like they use lactate, they use glycerol, and alanine into the liver. And even at levels that caused a 5-fold increase in uptake, and despite all the extra material coming in, the rate of gluconeogenesis didn't meaningfully increase. So what that really means to us is this: the liver doesn't just make more glucose because more building blocks show up, okay? Period. There was another study in the Journal of Clinical Endocrinology and Metabolism that compared a high carb, moderate carb, and a very low carb diet under equal calorie conditions. And what they found was that dietary carbohydrate content changed glucose production mostly by altering glycogen breakdown, not by messing with gluconeogenesis. So even on a very low carb diet, gluconeogenesis only increased by about 14%. That was at the high end, right? So yes, there was an increase, but it was modest. And here's the real key point here. That small increase likely reflects hormonal regulation, not even protein intake. On keto, your insulin levels are lower, so glucagon continues doing its job of keeping blood glucose within a safe range. And as long as insulin stays low and glucagon remains active, gluconeogenesis continues at a steady pace until enough glucose is present to signal insulin to slow down. So basically, everything's functioning the way it should. And another thing that rarely gets mentioned is that most of the material that's used for gluconeogenesis isn't even protein. In humans, over 90% of gluconeogenesis making carbohydrates comes from lactate, glycerol, alanine, and glutamine. Lactate and glycerol have nothing to do with dietary protein. They come from the breakdown of glycogen, and they come from the breakdown of fat, of triglycerides. Even the kidneys contribute significantly here because all of the glucose released by the kidneys comes from gluconeogenesis, and renal glucose output accounts for 20% of total endogenous glucose release. It suggests that roughly 40% of total gluconeogenesis has nothing to do with protein at all. So when people worry that protein is like kicking them out of keto, they are indeed blaming the wrong thing. Yet people never claim that eating too much fat is going to kick them out of keto, even though fats ultimately drive gluconeogenesis more than protein. So protein supports muscle. It's going to help your metabolic rate. It's going to help your overall adaptation. Aim for a minimum of 1 gram per pound of body weight, and you'll be in a much better spot than if you didn't. Which brings us to one of the most freeing rules of 2026 is that you can avoid or evade the keto police. Talked about this years ago. Keto is a tool, not a moral identity. You're going to get called a keto evangelist. You're going to get called a keto zealot. Remember, it's something that you're doing, okay? It's not you, it's not your identity. It is a metabolic strategy that you can use intentionally. I have talked to some of the most famous, literally famous people in the world that have had amazing benefits from keto, and they don't identify with it, right? This is where the so-called keto police usually show up, is if you identify with it to the point where you just become obsessed, right? So you almost have two sides of the keto police. You have the people that are gonna like hate on you, saying you shouldn't do keto, and then you've got the people that do keto that try to tell you everything you do is wrong. It's a lot more malleable and flexible than we used to think. It's not how physiology works, where it's like ridiculously strict all the time. There's research showing that carbohydrate refeeds can actually increase leptin and energy expenditure, especially after long periods of restriction. There was a study published in the International Journal of Obesity. Carbohydrate overfeeding increased plasma leptin 28%. It raised 24-hour energy expenditure while fat overfeeding did not. And I'm not a pro-carb guy. I'm just being real. Because what that really means, if we break it all down, is this: strategic flexibility doesn't undo keto adaptation. In most cases, it actually supports it. This is why for some people, doing a planned carb refeed for a week or two every 8 to 12 weeks can make sense, especially if keto is being used long-term. Now, that doesn't mean just having random cheat days and like eating a bunch of garbage. It doesn't mean abandoning the structure. It means understanding that temporarily stepping out of ketosis doesn't erase the work you've done. You don't need to let anyone shame you for it. Now, there's also another layer here that doesn't really get talked about a whole lot. There was a study that looked at endurance cyclists who had been on a long-term ketogenic diet, averaging 50 grams of carbs per day for over a year. So it's a long-term study. Compared to cyclists eating a standard diet, the keto-adapted group showed reduced glucose tolerance along with lower levels of GLUT4 and insulin receptor substrate 1 in skeletal muscle. These are the proteins that help move glucose into the cells. So in simple terms, they weren't as good at handling glucose, and their performance during glucose tolerance tests reflected that. So here's the important part of this. And that's that the type of glucose intolerance appears to be reversible. There's animal data that shows that after maintaining a ketogenic diet for about 8 weeks, glucose tolerance and insulin responses to a high carbohydrate meal are reduced. Yet when those animals return to a normal diet, insulin sensitivity and glucose handling normalize within about a week. Now, a week for a rodent doesn't translate directly to humans, but humans are generally better equipped to switch fuel sources, even better than rodents. So the takeaway here is don't have fear, right? It's all context. Temporary glucose intolerance on keto doesn't mean damage. And you can get around this by occasionally having carbohydrates and teasing that glucose tolerance a little bit better. As a matter of fact, when your body's not using glucose as well, it really just means you've adapted. And adaptation can be reversed when needed. Like you can get back to being carb adapted. So it does make sense to occasionally have carbs so that you can maintain this adaptation. So again, keto isn't something you have to defend. We need to change that. It's something you use, and understanding when flexibility helps is exactly how you evade the keto police from sort of both sides, those that are on the keto side and those that hate you for doing it. And this brings me to the second to last rule for 2026 that I think is very important. You need to stick with it long enough, an 8-week minimum. Okay, you have to stick with keto long enough for the adaptation to actually occur. Ketosis and keto adaptation are not the same thing. You could get into ketosis the second that you fast, right? That you're fasting and producing ketones. Okay, getting truly keto adapted, having that adaptation, that's an entirely different thing. Being in ketosis simply means you're producing ketones, right? Somewhere between 0.5 and 5 millimoles per liter, and that can happen super fast. But keto adaptation is something very different. Keto adaptation is the process where multiple organs, right? The liver, skeletal muscle, kidneys, mitochondria, even the gut, all are gradually adjusting to producing and using ketones efficiently. That whole process takes time. And early on, the ketone levels rise very, very quickly. Okay, so studies are showing that blood ketones can reach 1 to 2 millimoles within just a day or two and then plateau, even after months or years on a ketogenic diet. So the early rise tells you that ketosis has started, but it actually doesn't tell you how well your tissues are using those ketones. In fact, as adaptation improves, ketone levels stabilize or will even decrease. And it's not because keto stopped working, but it's because utilization has caught up with production. And this is why chasing higher ketone numbers can be very misleading and even detrimental and cause you to gain weight. So from a metabolic standpoint, what really changes during keto adaptation is more so enzyme expression and true mitochondrial function. So ketone metabolism relies on mitochondrial enzymes. They're required to actually use the ketones for energy. We have to build up these enzymes. And there was research published in Nutrients that showed that after 8 weeks on a ketogenic diet, there was expression of these key, what are called ketolytic enzymes, and they're significantly upregulated. So we're getting more of these enzymes. And we also know that mitochondria don't adapt overnight, although they do adapt pretty fast. We found that mitochondria have estimated half-lives of about 1 to 2 weeks. So reaching a new steady state where mitochondrial density and function are meaningfully different can really take, anywhere from like 2 to 10 weeks, depending on the tissue. Skeletal muscle adaptation follows kind of a similar pattern. There's studies that show that the first 1 to 4 days of keto, muscle glycogen drops really sharply and you're gonna have fatigue. That's pretty common in these first few days. And that's just because your body's adjusting to a lower AMPK state where glycogen is dropping. There was one classic study that they found that resting muscle glycogen fell to about 57% of baseline after 1 week. And exercise performance seriously suffered. Like people would lose their mind over this, but then after 6 weeks, muscle glycogen partially recovered and endurance performance actually improved despite glycogen still being lower than baseline. So there's like a signal as we are starving or losing glycogen that we like downgrade performance. But once that signal's better and not like signaling that we're starving, energy increases again, right? Things come back. So there's longer term data that's even more interesting because there was research on ultra endurance athletes consuming a ketogenic diet for over 20 months. And they found that resting muscle glycogen and post-exercise glycogen synthesis were similar to athletes eating high carbohydrate diets. This is an old study, but it's like a classic one. The mechanism still isn't fully understood, but it suggests that the body continues adapting like well beyond the first few months. So if you're an athlete, it certainly doesn't matter. Also, the kidneys adapt. Early in ketosis, ketones are lost in the urine, and over time, the kidneys become more efficient at reabsorbing ketones, which is another reason why urinary ketone strips become unreliable, right? Because basically you're excreting more. Sometimes you're holding on to more. Sometimes you're retaining it. Sometimes you're reabsorbing. It's a mess, right? So you can't always trust the ketone meters or the urine strips. Serum uric acid follows a very similar pattern. Levels often rise during the first 1 to 2 weeks of keto, and then they'll return to baseline after 4 to 6 weeks. Some people it might take a little bit longer, but even the gut microbiome adapts really slowly. We're starting to see some interesting research on this as well. There was an interesting human intervention study with people with MS, with multiple sclerosis. Microbial diversity initially worsened after 2 weeks on keto, and there was kind of an alarm there. But by a few months, diversity had increased and resembled that of healthy controls that didn't have multiple sclerosis. So what that tells us is something really simple, but really, really important. It's that keto adaptation is kind of dynamic, right? It's not linear. Basically, early discomfort doesn't predict the long-term outcome. Like taken together, the research suggests that meaningful keto adaptation truly takes weeks, and full adaptation can take months, okay, with continued refinements over time. So if you judge keto too early based on fatigue, based on stalls or ketone numbers, you're really evaluating the process before the metabolic machinery has really finished adapting. You have to stick with it long enough for the biology to catch up. Now, if we move on to the 10th and final rule for 2026, this is the one that ties it all nicely together. Keto only works if it fits into your real life, okay? It can't just be on a perfect day. It's not a controlled environment, okay? Your actual schedule, your stress, your travel, your training, your social life, all that matters, because one of the fastest ways that keto fails is not carbohydrates, it's friction, right? It's like when food isn't accessible, when you're extra stressed out, when the people around you don't understand. That stuff matters, because then every single meal feels like a negotiation. And from a physiological standpoint, this matters more than anything else. The more restrictive the keto feels, the harder that it is to stay consistent. And consistency is what is going to allow the adaptation we've been talking about to actually happen. So this rule is about environmental setup. Make the right foods easy to access, make it simple, have default meals you don't have to think about. Okay? Keep your kitchen stocked in a way that supports the way that you eat, that will actually work long-term for you. And just as importantly, be intentional about the people that are around you. No one else needs to eat keto if they don't want to. You don't need everyone doing exactly what you're doing. But you do need an environment where you're not constantly defending your choices. And I mean, I've been in this spot where I felt really isolated because of it. Like I chose a path that other people didn't want to do. And I lost friends over it because they defended carbs. And I'm here just like, I don't have a problem with carbs. I just want to eat this way, right? So when keto feels socially and logistically supported, it doesn't feel restricted. It's not the diet that's restricted. It's the clowns around you that make you feel that way. They'll start feeling normal if you don't view it like that. It's not about perfection. It's about making it work for you. Fasting's the same way. I did a video here that talks about how they compared 12-hour, 24-hour, 36-hour, 48, and 72-hour fasting in a study. It's really helpful for 2026 to understand what kind of fasting works best these days. So that link is right here. I recommend you check out that video. And as always, I'll see you tomorrow.